All right, so this is the first video for Unit 1, which is our Intro to Functions. The first page of the notes is just an outline of the topics we're going to be discussing. The second page then is where we're going to get started. So in this first video, we're going to learn all about understanding functions, domain, and range. A few definitions before we get started. A function is a special type of relation where each input has exactly one output. So let's define a relation next. A relation is a mathematical rule which assigns inputs to outputs. Okay, two more things to define. A domain of X typically is going to be the set of all inputs. So when you think domain, think X values. The range then is typically going to be your Y values. That's the set of all of your outputs. Let's take a look at a couple examples. So in example 1, we've got a set of points. So we've got the point 1, 0, negative 2, 3, 4, 1, and negative 3, 7. The first thing we want to look for is whether or not this is a function. When you're deciding whether or not it's a function, remember, each input has to have exactly one output. That means that each X value should really only show up once. If it ever shows up more than once, that's usually going to be a problem. So looking at our X values on number 1, we've got the number 1, negative 2, 4, and negative 3. None of those X values repeat, so we aren't going to have any problems. Yes, this is definitely a function. For the domain, that's going to be the set of all of our inputs, or the set of all of our X values. So looking at our X values, we've got 4 of them, 1, negative 2, 4, and negative 3. When we list those, we're going to list those in order from least to greatest. So least would be negative 3, then negative 2, 1, and then lastly 4. When we list off numbers, so when we list off numbers separately, we use a kind of curved bracket to signify that it's a list of numbers. We'll do the same with range. The only difference is that range will use the Y values for our function. We're still going to use the curved brackets and list them in order from least to greatest. So least would be 0, 1, 3, and then lastly 7. All right, let's take a look at another example. So number 2, let's first decide whether or not this is a function. So looking at your X values, we've got negative 5, 2, 1, and negative 5. This time, we do have an X value that repeats, and that's probably going to be a problem because the first time negative 5 goes to 4. The second time, negative 5 goes to 5. And we said in order for a relation to be a function, each input has to have exactly one output. This time, the input of negative 5 has 2 different outputs, which is a problem. No, this is not a function. If this second negative 5 had also gone to the same number, so let's say negative 5 went to 4, and then later on negative 5 still went to 4, then we would be okay. And it doesn't happen very often that it goes to the same number twice, but if it did, then we would be okay. And then you could have said, yes, this is a function. So let's talk domain and range. So even though it's not a function, it's still a relation, so it still has a domain and range. So the domain, we've got negative 5, 2, 1, and negative 5. If you ever have a number that repeats, like negative 5, you only list it once, but still write the numbers in order. So your domain for this particular problem would be negative 5, 1, and 2. For the range, we'll do the same thing, but with the Y values. This time, no repeats, so we're going to have to list all of these numbers out. Again, make sure to put them in numerical order. So 4, 5, 6, and then 7. All right. Let's next look at how to write domain and range from a graph. So when you're looking at a graph, in order to decide whether or not the relation is a function, what you want to look for and test is you want to look for the vertical line test. What the vertical line test says is that if you draw a vertical line through a relation, it should only pass through one point. And it shouldn't matter where you draw that line. So as I move this vertical line, notice that no matter where I put this vertical line, it's only going to ever cross my function once. So yes, this does in fact make this a function. Now, for the domain, we're thinking about X values. And so if you think about what x values this graph goes between, it actually goes to the left forever. So it goes to the left forever. That's really towards negative infinity over here to the far left of our x values. It also goes to the right forever, and to the right would be positive infinity. So we would say that all of our x values are between negative and positive infinity. And so we would use less than signs to say negative infinity is less than x is less than infinity. Another way that you could write this using interval notation is to use parentheses and say negative infinity, comma, positive infinity, both with parentheses. For the range, we're going to do something similar. This time, though, we're looking at how far down does our graph go and how far up does it go in relation to our y values. Well, it actually goes down towards negative infinity. It also points up towards positive infinity. So the range is actually going to be very similar. The only difference is instead of using x, we would use y and say that our y values are between negative infinity and positive infinity. Or with interval notation, again, just using parentheses, negative infinity, comma, positive infinity. Okay, let's take a look at another one. So on this next graph, on number 4, first thing we need to decide, is this graph a function? If I draw a vertical line through it, it should only cross once. This time, it crosses more than once, which is a problem. No, this is not going to be a function. However, we can still talk about its domain and range. So domain, if you look at how far to the left, what's our smallest x value, I'm going to round to the nearest whole number. And if you count over 1, 2, 3, 4, 5, 6, 7, our graph starts at negative 7. And then the largest, if you think about x values going to the right, our graph does point to the right forever, meaning that it goes out to positive infinity. So all of our x values are between negative 7 and infinity. Notice that with the negative 7, I use greater than or equal to because there is a point at negative 7. There's not a point at infinity. Infinity is not a point. We will never include infinity, so we would just use a less than sign. For interval notation, we would also make it a little different. The negative 7, rather than having a parentheses, would have a square bracket, whereas the infinity sign, since it's not included, would have a parentheses. Okay, let's talk about range for this one. So range for our y values. It does look like our graph goes to the right and also down. And if it's going down forever, that would be towards negative infinity. On the other end, it's going to the right, but also going up forever, meaning it's also going up to positive infinity. So with inequalities, we would say negative infinity is less than y is less than infinity. Or with interval notation, negative infinity, comma, positive infinity, both with parentheses. Okay, let's next talk about the difference between open and closed points. So, open points are going to get a less than or a greater than sign. This is also where you would use a parentheses to denote those using interval notation. Whereas closed points will get a less than or equal to or greater than or equal to sign, and this is where you would use a square bracket using interval notation. Okay, so looking at a couple examples on number 5, we've got this kind of line segment here. Notice that if I draw a vertical line, no matter where I draw my vertical line, it's only going to pass through the function once, which means we can say yes, this is in fact a function. For the domain, let's think about what x values we're between. So the smallest x value that we can get to is this point, which is at an x value of negative 2. It's got a solid point or a closed point there, which tells us to use a less than or equal to sign. So closed point, you use the equals to sign along with it. On the far right of our graph, we have the point at positive 2, but this time it's an open point, meaning we're going to use a less than sign. And then x in the middle, so x is between negative 2 and 2. If you wanted to use interval notation, you would use a square bracket on the negative 2 since it's included, and a parentheses on the positive 2 because it's an open point and is not included. For the range, we'll do something similar, but we'll look at y values. So the y values were between our negative 3, again less than or equal to since it's a solid point, and positive 5, in this case just a less than sign because it's an open point. And then again for interval notation, you would say negative 3 comma 5. Negative 3 would have the square bracket, 5 would have the parenthesis. All right, one more of these. So on number 6, let's first decide whether or not this is a function. It's a vertical line test. Drawing that vertical line. As I move that throughout my function, it's only going to ever cross once. So we are good to say, yes, this is a function. All right, for domain and range, let's see. For domain, smallest x value, negative 1, 2, 3, 4, negative 5. It does have a solid point down here. So we're going to use a less than or equal to sign. For the other direction, we go out to positive 1, 2, 3, 4, 5, 6, 7. Again, we have a closed point, so we'll use less than or equal to, and here is your inequality. With interval notation, you would say negative 5 comma 7, both with square brackets. For the range, we'll do the same thing, but looking at y values. So we go down 1, 2, 3, 4, 5, 6, 7, down to negative 8. Both of those points are solid, so we'll use less than or equal to. And going up 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to positive 10. Again, a solid point there. You don't exactly see an open point. So we're good to use a solid and less than or equal to sign with y, or negative 8 comma 10 if you're using interval notation. Okay, so on the next page, we're just going to do a little bit more practice with relations and functions. Just kind of as a side note, every function is a relation. That is part of the definition of being a function, is that if you're a function, you also have to be a relation. But that doesn't mean that every relation is a function. In fact, we've seen already a couple times where we had a relation that was not a function because it did not have that special property of each input having exactly one output. So let's do a little bit more practice with that here, and we'll kind of go speed round. So if you need to pause the video at any point to kind of write anything, feel free to do that. Let's take a look at number 1. So number 1, let's check our x values. Negative 1, 5, 8, 12. None of those repeat. So yes, we would say that this is a function. For the domain, we'll put those in order. So negative 1, 5, 8, and 12. They were actually already in order for us, which is always nice. For the range, we'll look at the y values, which are 3, 3, 3, and 3. So hey, range is actually going to be really easy to write because you don't have to list the repeats. So you just have to write down the 3. All right, let's take a look at number 2. So number 2, we've got x values of 0, 1, 2, and 2. 2 repeats, but it does not go to the same number. That is a problem. So no, this is not a function. But we can still list the domain and range. For the domain, least to greatest would be 0, 1, and 2. Remember to not list the repeats. For range, make sure those go in order, 0, 2, 3, and then 4. All right, for number 3, let's take a look at our x values. So we've got 9, 5, 8, and 9. Notice that the 9s repeat, but in this case, they actually go to the same number. We talked about this earlier. That's actually okay. As long as the x value goes to the same y value, then you're good. And we can actually say that, yes, this is in fact a function. For the domain, we would say that that was 5, 8, and then 9. For the range, we would say that that's 3, 4, and then 5. Okay. Next, we have some function maps, which are kind of fun ways to look at functions. The one thing that we want to look for is we want to make sure that there's only one place that the x value is going towards. So again, x values will always be on the left side, y values on the right side. And if you look, each x value only goes to one y value. You don't exactly have -3 going to two different numbers. It's only going to 2. And -1 goes to -5 and so on. So yes, we would say that this is a function. And our domain, we would look at our x values. They are already in order for us, so we just need to copy those down. -3, -1, +1, 4, and 5. For range, those are actually also in order for us. So -5, 0, 2, and then 6. All right, on number 5, looking at our x values, looking to see if any of them go to more than one y value. And there's a problem with 7. Notice that 7 goes to 1. It also goes to 4. That's a problem. This is not a function. Our domain, we can still list though. We would list off -5, or -9, -5, 1, and 7. And for range, 1, 4, 5, and 8. All right. For number 6, we have to kind of switch gears here to figure out if this is a function or not. Remember, for a graph, the way you tell is the vertical line test. And no matter where I put my vertical line, it's only going to ever go through it once. So yes, we would say this is a function. For domain and range, domain, it looks like going to the left forever would be -infinity. To the right forever would be +infinity. So -infinity less than x less than infinity. And again, interval notation, negative to +infinity. For the range, very similar. We're going down forever to -infinity, up forever to +infinity. So -infinity less than y less than infinity. And an interval notation, the same as the range, or the domain. All right. So very last thing, just a reminder, how can you tell if a graph is a function? Think about it for a second. We've done it a few times. That was the vertical line test. And that is it for the first section of our notes. And the next section, we'll talk about increasing and decreasing intervals. Until then, have a good rest of your day.